So here is another example of calculating average rate of change. So this is similar to number 8 or number 9 in the text. And we have find the average rate of change Unfortunately, there's not a global shorthand for this notation for that, of y equals 4x squared minus 2 from x equals -1 to x equals 3. So again, we have change in y over change in x. This one, unlike the one with the data chart, we have to figure out what the y values are before we can figure out what the change in those y's. So we need to figure out that we have 2 points. We have, if we think of f of x as 4x squared minus 2, we need to look at f of -1. Plugging in -1, we get 2. 4 times -1 quantity squared. And f of 3, we get 4 times 9 minus 2, or 34. So for this one, we have the rate of change between 2 points. So our change in y over change in x will be 34 minus 2 over 3 minus -1. So I'm going to go ahead and write that as 3 plus 1. And so we get a grand total of 8 for our final answer of the average rate of change of that. So what does that actually look like? What does that mean when we don't have any meaning attached to this? Right now we don't have any units for this because there were no units attached to the y or the x. But what does that mean as far as the graph goes? And what average rate of change is on the graph this is the slope of the secant line, which is a fancy name for the line connecting the 2 points. And so if we were to graph this, this looks like a parabola. And when x equals -1, we're on this side of the parabola, and when x equals 3, we're on that side of the parabola. And if we were to graph the parabola along with using a modified version of our point slope form, we have m equals 8, and we have the point -1, -1, 2. So we have 8 times x plus 1 plus 2. If we were to graph this along with the point, the parabola y equals 4x squared minus 2, we would see that this line does indeed connect those points on the parabola. Another thing that we should mention is that I didn't before, lines have constant rate of change So the average rate of change is their constant rate of change. If you were constantly getting 90s on your quizzes, your average would still be 90. So this is your slope. Average rate of change is the same. On lines. So on lines, the average rate of change is the slope. What we will talk about is other ways to measure more complicated parabolas, even more complicated than parabolas, for different rates of change.